Recommendations for electronic circuits prototyping. Use a 30-watt soldering iron to solder a component in Vero board. Use a soldering iron and sponge with water to clean the tip of the soldering iron. Use a good quality soldering wire to wire up your prototypes. Use a proper wire wrapping wire to wire up your prototypes. Use soldering fume extractor to protect yourself from the fumes of the soldering wire. Use a good quality tin-coated Vero board for your prototyping. In our previous session, we have interfaced 4 switches with port D of microcontroller, that is from port D4 to port D7. Now we will write a program to read the status of these switches and to show the status on port B. And here we can see that we have interfaced 8 LEDs with port B of microcontroller using ULN2803 Darlington driver. Here we can see from the schematic that 4 switches, switch 2, switch 3, switch 4 and switch 5, they are all connected on RD4, RD5, RD6 and RD7. The lower nibble of port D, that is from RD0, RD1, RD2 and RD3 is not connected in our circuit. And if we'll read these inputs, the status of these inputs will be high in our program, and the corresponding LEDs, that is from RB0 to RB3, that is from RB0, RB1, RB2 and RB3 will be high. So the LEDs connected with these ports will be on, and we can only control the status of RB4 to RB7 using these switches. To write our program, we'll use Micro C compiler. Here in Macro C, first we'll close all projects. Close projects. Now we'll go for new project, project, new project, the standard project, next. And the name of the project is read switches. And the project folder will be, we'll create a new folder here, and the folder name is switch programs. Okay, and here we have the folder path, that is E, Micro C projects, switch projects. The microcontroller is PIC16F877A. And the device frequency, that is the clock frequency for the microcontroller, is 10 MHz. Okay, next. Finish. Here we have our new program window with the name that reads switches. Now we'll write some comments and assignments. Read switch program. Now we'll assign the names to our ports. Port assignments. That is define LED port, port B, as we have connected 8 LEDs on port B of microcontroller. Here we'll assign the comments. LEDs are connected on port B. Now we'll assign the name to the port D, and we have connected 4 switches on port D. So we'll use define SWPRT port D, and we'll add comments here. Switches are connected on port D. Here we have completed the assignments for our ports. Okay, now we'll write the main program. And here we have our main program. And here we have our main program starting from void main. And here in main program, first we'll set the directions of both these ports, as LED port is output port while the switch port is input port. So we'll write trace B equals to 0B 0000 0000. It means that all 8 pins of port B are declared as output. Now we'll write trace D equals to 0B 1111 1111. It means that all ports of port D are declared as input port. Now we'll write the while loop for our program. From while 1 and here we will write our program between these two braces. We will just move the status of switch port to the LED port. So we'll write LED PRT equals to SW PRT, and that's all. It is a simple program to read the status of switches and to print the status on port B. Now we'll compile our program and we'll observe the result on prototype. Okay, first we'll save the program. And here we can see the program is compiled successfully and hex file is created. Now we'll download the hex file to the microcontroller. For this, I'll connect PIC3 programmer with the programming port of prototype. Here we have connected PIC3 programmer with our hardware. Now we'll start the program for PIC3 programmer. And here we can find the controller is detected. Now we'll go for File, Import Hex, and here in Switch Programs folder we have Read Switch Hex file. Okay. Now we'll download the hex file to the microcontroller by pressing right button. Okay. Programming successful. Now we'll power up the hardware. Here we can see the status of input from port D0 to port D3. As these ports are unconnected, so their status is unpredictable. But all these ports which are connected to these switches, their status is known. As the switch is not pressed, the LEDs are high. If I'll press any switch, the LED will go low. Here we can see port RD4 is low, port RD5 is low, port RD6 and port RD7. Now in same program, we'll use invert logic for all ports which are connected to port D4, port D5, port D6 and port D7, and we'll print an invert logic on port B from port B4 to port B7, and we'll also mask all these 4 LEDs in our program. We'll modify the same program to avoid printing all these 4 bits which are not connected on port D. As we have connected 4 switches with port D of microcontroller, the lower enable of port D, that is from port D0, D1, 2 and 3. All these 4 pins are not connected in our circuit and these pins are open. So if you'll read the status of these pins, the status of these pins will be uncertain for microcontroller. So sometimes it will take it as high and sometimes these pins can be read as low. In our new program, we'll mask all these pins. and will print the status of these pins on port B after masking, while the higher enable, that is from port D4, port D5, port D6 and port D7, we have connected 4 switches with these ports, and the logic of all switches is active low. It means that if no switch is pressed, the status of input will be high, that is 1, 1, 1, 1. So if we'll print the status of these pins on port B, LEDs will be on as we have seen in our previous program. Now we'll invert the logic of these pins, as we know that the XOR logic, if we have 2 inputs, that is A and B, and these 2 inputs can have 4 combinations, that is from 0, 0, 0, 1, 1, 0 and 1, 1. For the same logic, XOR output will be 0, and here we will have 1, and again here we will have 1, and we'll have 0 on 1, 1. So we'll use the XOR logic to invert the status of switches. We will XOR the port D with 1, 1, 1, 1, 1, 1, 1, 1. It is equals to 255 in decimal, and we can write in binary, that is 0, B, 1, 1, 1, 1 and 1, 1, 1, 1. We can assign the value in decimal as well as in binary. We can also assign the value in hex format like this, 0xFF H. We can assign the values in all 3 formats, that is in decimal, in binary and in hex. As a result of this logic, we'll have 0, 0, 0, 0, and the status of lower enable is still undefined, so we'll mask these inputs. We will use AND logic, and we'll end the result with 1, 1, 1, 1 and 0, 0, 0, 0, which is equals to 240 in decimal, and we can write in binary like 0B, 1, 1, 1, 1 and 0, 0, 0, 0. We can also assign the value in hex, that is 0x F0. So here we will perform 2 operations. The first is XOR and second is AND with the switches which we are reading in our program, and will print the status of output to the port B. Now here in our program, first we'll XOR the port with 255. And to perform the XOR logical operation, we'll use the symbol, and we'll XOR the port with 255. Here we can write 255. We can also write the number, that is 0B 1111 1111. So it will invert the logic. We can write the number in hex format, 0xFF. So we can use the numbers in our program in 3 formats, that is decimal, binary and hexadecimal. Here we will use the number in binary format, 0B 1111 1111. Now we'll compile the program. Okay, there is no error in our program. Now we'll perform the AND operation. For this, we'll place this operation in brackets, and we'll use AND with 0B 1111 0000. Here we have masked the lower enable of port D, and we are sending the value to LED port. Now we'll compile the program and we'll test the result on our prototype. Okay, compile the program, and here we can see program is compiled successfully. Now we'll download the hex file to the microcontroller. Here we have Picket3 programmer. We'll use the same file which we have downloaded previously. We'll go for the file, import hex, read switches. Okay, now we'll download the hex file to the microcontroller. Now we'll power up the circuit and we'll observe the result of our program. Here we can see all LEDs are off. It means that lower nibble is masked, and we'll check the status of switches on higher nibble of port B. So first I'll press switch 1, LED is on, switch 2, switch 3 and switch 4. Here in this program we have read the status of all 4 switches simultaneously. Now we'll use the function of micro C to read these switches as button.